Arknights Endfield is currently still facing a problem. There's not really much content. Yeah, sure, I like Traverse's story quests, and there's new Umbral Monument content, but I cleared all of them in a day. So now, I keep checking the events page over and over again and farming essences for literally no reason until my sanity goes negative. There's really nothing to do, man. Like, there's no endgame. A 7-segment display is an electronic device used to show numbers using 7 individual light segments. This can display numbers from 0 to 9, or even some letters. By inputting a desired number, certain segments turn on to display that number. We can also do that in Endfield by manipulating where the items can go to in each segment. All we need to do is figure out how to get the individual segments to work together to display what we want. By labeling each segment with a letter, we can construct a truth table for them. So for example, if you want to display the number 4, we input the binary form for 4, which is 0100, resulting in F, G, B, and C turning on, while displaying 8 or 1000 turns on all segments. Each segment now has a condition, and you can create a Boolean equation by using the kernel map, or K-map for short. I use the K-map calculator because I'm lazy, and by following the order by the output for each segment, I got these equations. The outputs are determined by A, B, C, and D, which is the binary form for a desired number. Letters with bars above are nots, so when the input is 0, A bar equals to 1, and A equals to 0. Plus signs are ORs, so for example C, this means that when the input C equals to 0, or B equals to 1, or D equals to 1, then output C is equal to 1. Letters combined together are ANDs, so for example E, this means that when the inputs B equals to 0 and D equals to 0, then B bar D bar equals to 1, or C equals to 1 and D equals to 0, then C D bar equals to 1. Hence, E is equals to 1. But how do you even represent all this in Endfield, you might ask? Luckily for you, I already did that in my previous video on the 2-bit adder. Very briefly, this is an OR gate, this is an AND gate, and this is a NOT gate. To represent our ABCDs, we use plants. Please watch it if you haven't. Now, we pretty much have everything, and we can start making the circuit. Except, it's supposed to show 4. Why is the middle not on? Okay, now I need D. Oh, wait, I blocked it. Oh my PC! The connection is wrong. I'm having so much fun! Wow! Everything was going wrong. You see, Endfield is not designed to be a circuit diagram creator. It's a factory game. There's bound to be limitations to space, number of objects, horrible wiring, inconsistent signals, and many more. Like, what even is this? I still have no idea how to increase this. So, I had to find ways to manipulate the diagram. If you were to wire up every AND gate to each individual segment, that means you need to have 15 protocol stashes and another 15 more to store the redundant signal, which means I need to split each input like 8 times, which is tedious. I realized that some equations had the same conditions. For example, output B and F has C bar D bar as a condition. So, if I can just make one AND gate and split this into 2, I would only need 2 protocol stashes instead of 4. By rearranging the equations a little bit, we can group the segments with the same condition and focus on the important ones. I also realized that the redundant signal of an AND gate can also be used as an OR gate. If either of the inputs is on, they will always output to this signal. We can use this to our advantage to save up space. In Boolean algebra, there is a rule called the distribution law. Similar to algebra, xy plus xz equals x times y plus z. So for example f, b c bar plus b d bar can be represented in b times c bar plus d bar. To get c bar plus d bar, we can get it from segment B, which has c bar d bar as a condition. From the protocol stash, this part is c bar d bar, and this part is c bar plus d bar. Then create another protocol stash having b and c bar plus d bar as the input, outputting b times c bar plus d bar. The other output is redundant because there is no other segment with that output. By rearranging the equations again, we can link segments like so. Can't just connect a wire simply by dragging from one point to another. At the very last few segments, I wasn't able to connect D because I blocked it off. So I have to spend another 20 minutes wiring it up again, just to forget that I blocked off C as well. So the wires need to act as rungs, so I can just place a splitter whenever I need it. I decided to place them this way. In the previous video, I said, ran out of ports, make a new farm. But if you count the number of times each input is present, I would need more than just a new farm. Note that I would need to create farms for the NOT gates as well. Clearly I have no space for that, so instead, I use water farming plants and shred it at the end of the output. I also said in the previous video that using a splitter halves the input, which can cause problems. This is true because if the inputs are offsetted perfectly, it won't even output, and some segments turn on more often than others due to the splitters. Every time when a splitter is placed, the path gets halved. Putting more splitters halves the halved input, which doesn't make all splits even, so I had to put more splitters and convergers to regulate each path as evenly as possible. With most problems out of the way, now we can start making the circuit. We first need to get the bars of each input, have a force signal with Yatsen, and get one of the input ports to cancel out the NOT gate with Jintao. And do this for all inputs except A, because there is no A bar found in any of the segments. Then, create the rungs like so. We need some space for the splitter regulator. Then, start creating the gates. I always start with the AND combinations that don't need linking on the right, and combinations with links on the left, so that the next segment equation can link up easily, and those with single variables can be connected to any converger. Then, add a shredding unit to make the signal look more consistent, and finally, link up the outputs to its respective display segments. And there you have it, a 7-segment display in Endfield. To display something, input the desired binary number, for example, 7, place units according to 0, 1, 1, 1, and you get 7. Here are all the numbers. It's not the best because of the inconsistent signals, but it is as best as I can get it to work. Maybe this is what Endfield is about. Not about getting the highest damage or the best team. We are the administrators, tasked to run Endfield Industries to solve real-world problems and to help others with tech. I've done it. I've achieved true endgame.